you can see there are three types of addressing modes we are having, but before we start with the addressing mode, we need to understand first what is an addressing mode actually is. Fine, because if you do not know what is an addressing mode and what it deals with, we may not be able to understand that classification in detail. So first thing first, you can note down the concept of addressing modes are only revolving around or focused on the operands. They will hardly deal with the opcodes. They will deal with the operands only. Fine. So whenever we talk about addressing modes, just keep in mind that we are talking about the operands only, the data only. Fine. So what if I have to tell you in a single line definition of an addressing mode? It may simply be like addressing modes are various ways to specify operand, write data in bracket, various ways to specify operand at various locations. At various locations like registers, pointers, memory, etc. So wherever this operand is moving, that movement of operand is given by a title. Fine. That title we call collectively, all the titles is called the addressing mode. So what they are doing, they're tracking the movement of the data and giving us that title that right now operand is lying in this particular area. So that's why this is called this type of addressing. Okay, so is that clear? Simply, it's just simple. Various ways to specify the operand, single line definition. That's it. Fine. Rest you will understand after this class, or when you will go through the types of addressing modes we are having here. Okay, so there are three classifications of these addressing modes. First is data addressing mode. Second, we have program memory addressing mode. Third one is stack memory addressing mode. Fine. So if I talk about your syllabus will only give you data addressing mode. They will not deal with the program memory addressing modes or stack memory addressing mode. Only the data addressing mode will be. We will be studying only the data addressing mode. Fine. Let's move further. Under this data addressing mode, there are 7 types of addressing modes in 8086. Fine, and they will be common for 8088 as well. Okay, so I've already discussed that addressing mode means the method by which an operand can be specified in a register or a memory location, or it can be anything else also. So first is the register addressing, then we have immediate addressing, direct addressing, registered indirect addressing, base plus index addressing, register relative addressing, base relative plus index addressing. So we'll go one by one. So let's start with the registered addressing. So before we go with the register addressing, let's have a revision first. What we know about opcode and operand. Like we have an example, move AX, 1000H. Move AX, 1000H. So in 8086, MOV is the opcode, AX, 1000H. They will be treated like an operand. Alright, so they will be treated like an operand. MOV will be your opcode. Fine. So we remember that opcode is the operational part, operand is the data part. Okay, then let's start with the actual addressing mode. So what happens in the register addressing mode? First, try to understand. If you want to write, you can write, but just try to understand what is happening here. Just look at the example, then we'll read the theory. Read the example first. Move bx comma dx. I've already given you few things that whenever we have move means a data transfer kind of operation. The syntax is mov space d comma s. Fine, d stands for destination, and after comma it is s, that means source. So source here is dx and the destination is bx. Fine, so arrow is like from dx to bx. All right, so what we have here is, look it, we have bx comma dx, we have es extra segment register comma ax, add al comma bh. Now look at the important thing here. What is common when you're looking into the source as well as the destination part? What is common here? Anyone? What is the common stuff here? All of them are registers. bx, dx, es, ax, al, bh, they all are registers. So this is what the register addressing mode is. It is the play between two registers. The source is also a register and the destination will also be a register. Only thing that you need to take care is the size of the source and the destination register should always be same. Fine, so register addressing mode will be applied or will be considered when there is a movement of data from one register to another register of the same capacity. Nothing else, just a play between two registers, that's it. Is that clear? Register addressing mode, is that clear? It's nothing, it's just play between two registers. If the destination and the source both are registers, then the addressing mode is called the register addressing mode. All right, so let's move to next. This is a few examples. Fine. Now, if you look from top, move al, comma bl, ch, cl, they all are verified. But when you look at these, move ecx, comma ebx. This is a 32-bit instruction. Fine, that we'll study later, these two 32-bit instructions, how they will be operating in the instruction set. But there are few instructions which may not be allowed, that you need to take care for your competitive exam, interview and quizzes. Move es comma ds, this is not allowed, although they both are segment registers. Fine, extra segment comma data segment. Now see what is happening here. Data segment holds the starting location of the data segment. Fine, but what is the job of the data segment? Data segment is the place where all your operands will be stored. All right, so this particular segment should not be interfered with any kind of data transfer, because that may disturb the elements inside the data segment. So whenever you are taking data ds or dx, you cannot treat data register or the dx register as source. No. Fine, so ds को आपने कभी touch नहीं करना है. ds means data segment register will never be the source of any data transfer. All right, next is move bl comma dx. Now you can see l means 8-bit, x means 16-bit. That is not possible, we have already discussed that. Same thing happens in the next one. Move code segment comma ax, 16-bit accumulator is getting copied into the code segment register. Fine, that is also not possible, because a will be having the data, the content, and you are going to copy that thing inside the code segment, which will be having only codes. That thing is logically wrong. So I may give you few instructions, identify wrong ones or not allowed ones and others. Fine, so always look at the instruction. Is that clear? Is that clear, yes, all of you?
Yes, sir.
All right, better. So next we have is immediate addressing mode. One thing more, whenever we're talking about the addressing mode or you are explaining addressing modes, and this question with my experience is continuously coming from last 10 to 12 years. You will have a straightforward 10 to 15 marks question. Explain the addressing modes of 8086 by proper examples. Fine. Straightforward as it is. So that thing will be very important. Fine. So next we have is how to attempt it. Addressing mode should be provided with examples. Examples are must. Explain your example rather than writing the theory straightforward. Explain your example. That in this case, this is source, this is destination. What is happening? This is happening, and this is the case. That's it. Fine. Explain and work on your example rather than a straightforward theory. And if you are missing out an example, trust me, you will not get the full marks. Your attempt should be to get 10 out of 10. Okay, so make it a little graphical. Fine, do not write a paragraph. And examples are must in addressing modes everywhere. Okay, so immediate addressing modes. Let's come to the example again. That's why I focus on the example. This is the text written over there. Neither you want to read it, neither I want to read it. I want to make you understand by this. This is how you want your examiner to see the things. It will simply look into it, and if the example is correct, trust me, it will take it like theory is also correct. But if example is wrong, theory is correct. It will take it like both wrong. So you have to be very careful while attempting the question. Alright, so next we have is immediate addressing mode. Now look at the examples. Move space AX comma 2550H. Fine. Now look at the source and destination. I told you in every instruction there will be a source and there will be an instruction destination. So here AX will be your destination and the source is this 2550. Fine, we are directly loading a content or the data inside the register A, and it is also 16-bit. 2550 is 16-bit. So in this case, what is happening? We are loading a content directly inside the register. This is your data immediately getting copied inside a register. Immediately, no other register is transferring. We are saying we are moving or copying or loading 2550 into AX immediately. Like I say, load the first number in register A, load the second number in register B. So immediately move AX comma first number, move BX comma second number. So whatever number you are having right now, 2550 is your data number. H stands for hexa. The size says 2550. It is of 16-bit. Fine. Next example, move CX comma 625, but there is no alphabet in the end. That means by default it will become decimal value. 625 will be a decimal value if there is no alphabet in the end, like H for hexa, O for octal. Fine, binary so different ho jayega, 0101, and what we are left with the decimal. So always think about this thing. H hexa, O octal, nothing decimal. So 625 will be loaded like a decimal value inside the register C. Alright. Now look into the next, move BL comma 408. This time same process is happening, but what is the new thing? New thing is 40 is an 8-bit data, and BL definitely it is an 8-bit, so it is loading 8-bit inside then 8-bit. So what is happening in the immediate addressing mode is we are immediately loading the data inside a register. That's it, nothing else. Immediately I say load this particular number inside register A. So this will be the instruction that you can use. Simple. Okay. Next is look at the bottom examples. Look at the bottom examples. Move AX comma 2550. Okay. Then we have move DS comma AX written in the first line. Agreed? This is like your previous one. Move AX comma 2550 is the current example of immediate, but next which is written move DS comma AX. This is example of register addressing mode. Now understand the concept here. Now look into the bottom line, move DS, 0123. This instruction is illegal. Why it is illegal? Because DS is your data segment register. Fine. Now note down the rule. If you want to load a data or a value inside a register which is a segment register, DS, SS, CS, anything, what you need to do first that value should be moved to a general purpose register like A, B, C, D. Like we have loaded 2550 inside A. Now that AX content is getting loaded into the DS. Alright, so same thing we are looking over here, move DS, 0123. It is looking perfectly from the immediate, but logically it is an illegal instruction, because in the data segment you cannot load a value directly. It will come from program. आप segment के data segment के अंदर immediately value को copy नहीं कर सकते. It will come by the example or it will come by some register. Okay, is that clear?
Sir,
all of
the
you?
Last one is the one is complete, na? Complete.
Yeah, in the bottom there are two lines. When move AX, 2550 edge, this is one instruction. You can write the next instruction, move DS, AX in the next line. They both are perfect. Fine. Now leave some space, then write move DS, 0123 and mark this thing as illegal. This thing is logically wrong. Fine. So isn't it better to explain everything from the example rather than this stuff?
Yes, sir.
Fine. Always work on your examples. Fine. So let's have one next one. So this is the list again that slowly you will utilize while the programming. Now come to the next, data addressing mode. Oh, sorry, direct addressing mode. Third one is direct addressing mode. Fine. So now I'll give you a few tips and tricks to remember what will happen next in the addressing modes. Fine. So in this direct addressing mode, wait, the data is in some memory location, or it can be plural locations, and the address of the data in memory comes immediately after the instruction. Now what happens here? Theory is maybe different. Now look at the new stuff. What we are having here is bracket. Look into the bracket. This is the indicator of direct addressing mode. This is the indicator of direct addressing mode. Fine. So whenever you have anything inside the bracket, this means it will become a memory location. So what happens here is 2400 is a content. It's not data, it's not address. Fine. Is a content. Fine. We loaded into it which location it is. It is a source location. Then we provided bracket to it. Bracket जैसे लग जाता है. The moment it is enclosed in a bracket, that means it's a memory address. So where it lies. So data का D, direct का D याद रखो. Fine. And which segment? D is already data segment. So direct का D and data का D. दोनों को match करो. Direct addressing mode is simply related with the data segment. Fine. So data segment के अंदर का location होगा. It will be inside the data segment. 2400 will be a location inside the data segment. Fine. So always look for this D. D से याद रखो. D for direct, D for data, D for direct, D for data. So whenever we have this thing in direct addressing mode, it will always look for the physical address by combining the DS as your base address and 2400 as the offset. So if we want to calculate by using the DS value, the physical address formula will be what? The value of DS multiplied by 10 plus 2400, which is our offset. Fine. So direct D data. Fine. Bracket. So whenever we have bracket, whatever is inside the bracket, that will become a memory location. But memory location inside what? Inside which segment? Only the data segment. Only the data segment. Is that clear? Is that clear?
Yes, sir. Yes, sir.
बस D का डायरेक्ट D
Yes,
का
yes.
डेटा याद है. Fine. Let's have few more examples where we are asking to find the physical address of the memory location and its contents after the execution of following. Assuming DS is equal to 1512. Fine. Move AL, 3BH. First instruction is the immediate move AL, 3BH. 3B is getting loaded inside the AL immediately. So after this, AL will have 3B inside. After AL is right now acting like source. The content inside 3B will be the source, and what will be the destination? Destination will be 3518, and where this will be 3518 will be inside the data segment. So if we want to calculate the physical address and if you want to write it logically, like we have seen in the last class, logical address will be DS oblique 3518, because right now 3518 is acting like offset. Fine. DS is 1512 given in the question. So you can write it like 1512 colon 3518. Fine. Once we have this value, you know the formula. 1512 will be multiplied by 10 plus offset, then answer will come out to be 18638 as your physical memory, physical address. Alright, so this is how the calculation can be done. Is that clear? Is that
Yes,
clear?
sir.
Yes, sir.
Better. Now come to the indirect addressing mode. Register indirect addressing mode. Fine. In this, the method is related to some indirect phenomenon. There is no direct phenomena. We have an indirect phenomenon. Look at the example. Here, in the first example, MOV space AX, comma BX, which is enclosed in the bracket. Now what happens here? In the direct case, inside the bracket there was a value, but right now it is not having any value. What it is having? It is having some register which will give us the value that will act like offset. Alright, direct, indirect, difference समझो. Direct means direct value will be given. The offset will be directly given. Fine. But in case of indirect, there will be an indirect path. Fine. So there will be a register which will be holding the value, acting like source, or it can also be destination. Fine. The value of that particular register will be copied first, then it will be calculating the physical address, then the transfer takes place. So it is not a direct path, it is an indirect path. So पहले bx से value आएगा, फिर उसका हम physical address calculate करेंगे, फिर वो transfer होगा. Alright, so this is the indirect approach. In case of direct value, we are having a register which is holding a value that will be treated like an offset. Fine. Again the segment which is going to be utilized here is DS only. Fine. So if we take the example first one, which moves the contents which is highlighted by the location given by the register BX. Now let's say BX is given as 1234 and DS is given as 1000. Fine. So first we need the value of BX as well. Fine. Now look at the indirect path. In place of the direct value, now we have first BX. The first value comes from the BA. Then it will be loaded into the physical address calculation. Alright. So this is how things will come in the indirect phenomena. Just hold on for a second. I'm getting a call. Okay, is that clear? Register indirect? Register indirect clear hai?
Yes, sir. Yes, sir.
Okay, the difference is only one. In place of the direct value, there will be a register. That's it. Nothing else. Okay, now look at the bottom. There are two given examples. Move CL, comma, SI and DI age. So they are also applied for the source index as well as for the destination index. Same thing. So whatever is inside the bracket, that will be treated like a memory location. If there is not a direct value, there will be some register involved which will give us the memory location. Okay, so this is what we call the indirect path to address the data operand. That's why it is called indirect addressing mode. Okay, this is the example that you can do by yourself. Now come to the next one, the base addressing mode. Next one is called base addressing mode. Fine. Now look at the example. Move AX, comma, bracket again. That means whatever is inside the bracket, that will be treated like a memory location. So what we have inside is BX, BX plus 4. So what we need in order to calculate, what we need now, we need the value of BX and the value of DS, because data segment opcode, operand data segment. So whenever we talk about addressing modes, DS will be the only segment that will be involved every time. Fine, because we are talking about movement of operand only. Where operands will move, they will move only in the data segment. Fine. So by default, your segment will be the data. So what we have here, logical addressing DS colon BX plus 4. The offset will be your BX plus 4, which is inside your bracket. Fine. And that value will be copied inside the AX. So how to calculate the physical address now? Simple. DS multiplied by 10H plus BX plus 4. So now we need the value of DS and the value of BX so that we can calculate the 20-bit physical address. Fine. Next, what we have is BP. Base pointer. Base pointer can also give you this base addressing mode, but in this case, the segment will change. Because now what we are having is we are having a pointer. Base pointer is having a route to the stack segment. Whenever we talk about the base pointer, its route is from stack segment. And when we talk about the base register, register is BX. BX is having its route into DS. Pointer comes from stack. So simple thing, nothing. In place of DS, if base pointer is getting utilized, it will be having SS in calculation of physical address. So in total, now look into the overall stuff. Base, whenever base is getting involved, the capital word B will be involved. With B, there are only two registers which are involved, BX or BP. Base register or the base pointer. So they will be given by only two registers, BX or BP. That will be giving you base addressing mode. No other can give you the base because base is not involved. Simple. All right. Is that okay?
Yes, sir.
Okay, then come to next.
Yes.
Now things will be collaborative. Like here we are having base. Now look into this. We have same phenomena of calculating everything. Move CH comma bracket SI comma 5. Move AH comma DI plus 1. Now look at the overall index addressing mode. Which registers are getting involved? SI and DI. We know how to calculate the formula of physical address. DS data segment multiplied by 10 plus offset inside the bracket SI plus 5. Same for DI plus 1. So what is happening here? Base was using only BX or BP. Fine. Index is using only SI and DI. That's why they are called इंडेक्स एड्रेसिंग मोड. फाइन, सिर्फ लेबल से आइडेंटिफाई हो जाता है BS, BX और BP, इंडेक्स, SI और DI, नथिंग एल्स. फाइन, बट इफ आई कंबाइन बोथ ऑफ देम, दोनों को कंबाइन कर देते हैं, देन इट विल बिकम मोर पावरफुल. फाइन, नाउ लुक एट द एग्जांपल. मूव BX plus DI comma CL. Fine. So what is happening here? The contents of CL acting like source, but the destination is BX plus DI. Alright, BX plus DI. Now in order to calculate the physical address, हमें पता होना चाहिए इसका कि DS कहाँ है, BX कहाँ है और destination index कहाँ है. So base plus index, when they both are being utilized in an addressing mode, we need the value of everything: data segment, BX and DI. Alright, so there is nothing in this. We are just combining base and index. So whatever is inside, we are having inside bracket. That will be your offset address, and that will be utilized in formula where we have to put the offset address. So offset address here in the first example will be given by BX plus DI. In the second example, it will be given by BX plus SI. Next example, we have pointers, BP. Fine. Like I told you, whenever BP is in the action, the source of BP or the segment which is associated with BP is stack segment, SS. So while calculating the physical address, when BP is involved in an addressing mode, always use SS. Fine. Otherwise, this thing is as usual. There is nothing complicated happening here. Just a combination of two things. All right. So let's have the revision quickly. Register addressing mode, or first the definition: addressing mode stands for, addressing mode basically relates with the movement of operand at various places. Now you must have seen we are talking about register, immediate, direct, data segment, indirect path, base, index, relative, base, relative, so many. Fine. So first one is the register addressing mode, where the source and the destination both are registers. Immediate addressing, where immediate data is getting loaded inside a register immediately. Segment register, which is particularly data, it will not accept it exactly. First, the value is to be copied into the accumulator or any other register, then it will be shifted to data segment register. Next, we have direct addressing mode, the launch of bracket. Inside the bracket, there will be a value which gives us the memory location of the data segment. Direct D, data segment D. D se yaad rakho. Indirect, there will be a register inside the bracket which will be giving us the offset value to calculate the physical address. Fine. Next we have base. Base means BX and BP will be involved in calculation. Index, SI or DI will be involved in calculation. Base plus index, both will be involved in the calculation of the physical address. Fine. Now there is